Hi everyone, thank you so much for this opportunity for to speak about this topic that's close to my heart. And whoever is listening from all over the world, I'm very, very grateful for your time. So my name is Geetha. I'm currently a customer success manager at Pure Storage. I used to work at Temporal before this as a staff solutions architect, helping out customers build reliable solutions, reliable applications. Um, uh, During my time at Temporal, I came across this framework, which is open source, but relatively not known to developers. So that's why I was making an effort to spread my knowledge. Before Temporal, I worked at a couple of open source backed companies like Elasticsearch, Confluent, Cloudera, and ServiceNow. I started my professional journey as a software engineer and then eventually moved into customer facing roles like solution engineering, pre-sales, post-sales, architecture, and business. And now I've moved into the business side of the house. I'm so excited to speak about it. So let's get started. I've wanted to discuss the challenges of building distributed systems, right? And how certain elements of making choices while building these systems will affect the final outcome. Things like idempotency, systems being idempotent, having durable execution, meaning also making sure that the systems are deterministic. All these things are very crucial, although they're considered like really casual elements. As a developer, you always have to take care of all these edge cases in order to simplify the app development and then um, improve the velocity at which you develop things. So in modern day, architecture is somewhat what you see on screen. There are multiple workflows involved. There are in any industry you take, there are process oriented. There are different kind of microservices that are weaved together to perform a shared task. And then there are functional calls going on from one app to another app, and possibly all these apps are connected by some kind of queues or Kafka topics or databases and other kind of distributed elements that make up a stack and a pipeline. So what happens is that it's really efficient, and all these systems that are built many decades are very efficient, and they are built to scale, and they are meant to be easy to maintain. That's what the goal of modern application development is like. But what happens is that everything is fine and great until it is not. So what can go wrong will go wrong, and Murphy's law will suddenly start to play out. So the modern applications, they're super powerful, built using the event-driven architectures and whatnot. They are powerful until they become challenging. So the databases that are involved are sometimes meant like inevitably will fail. There is some amount of discrepancy that you see in data. The APIs, even though how well written they are, sometimes they experience failure, and then downtime of APIs is pretty common, timing out, errors, exceptions. These are all things developers deal with on a daily basis that will eventually lead to a process failure. And how do you handle all these point failure things? How do you roll back the state? How do you make sure the task is prioritized beyond the point when the disaster strikes, right? You need to have a retry mechanism that's overall takes care of the process flow without any data interruption or business continuity loss. And all these things have to be kept in mind. And then we still have a challenge left, meaning which is how to do it in a consistent fashion. How do you make sure that all the existing long running processes are not disrupted? Um, as I mentioned before, how do you make sure the transactions are idempotent, the systems are deterministic? How do you share the state across all these services consistently, being in sync with each and every service, seeing the same UI, seeing the same data layer that they should? And then When multiple services involved, failures are inevitable. How do you guarantee all these kind of transactional elements, right? That's the challenge at hand. Some of these challenges were handled by event-driven architectures, as you probably know, has been a phenomenon that was widely accepted across companies. It still is a great way to host applications, great way to make sure that the data in the form of messages is reaching using a queuing fashion. The databases that are involved are keeping up with the Kafka or whichever message queue topic that you do have, and the configurations are centrally managed while they're being distributed. And all these things that you see on screen, all the elements of event-driven architecture are really great and sophisticated. But one thing is very, very common in these EDA architectures is the complexity. Meaning, the larger the distributed system grows, the complex it becomes to operationalize it and increase the velocity and also make it reliable. It's the challenge at hand. Our desired goals of building and a reliable application is to have high developer velocity and also make sure that the operational efficiency is in place. All these KPIs, all these metrics are directly at odds with the system complexity. And as the complexity increases, our velocity and the reliability will suffer, which can be detrimental to any business. So our goal is to make sure that the velocities is high, the reliability is also high with lower complexity. That's where the durable execution comes into place with temporal.io. It's an open source framework. It can simplify your app development, make them more reliable, and it can help you with delivering features faster. Um, so temporal is a new category of solution development. It's a new category for system development and operations. Underpinning this whole framework is the concept of durable execution. So durable execution is to say that your systems are meant to be built to never fail. There is no negative result for any input that you give. The output is always going to be the same. Even though the system fails intermittently, there will be retry mechanisms that will be built in so that the developer doesn't have to natively handle it. That's the whole goal of temporal workflows and other elements. So some of the building blocks of temporal IO is building a workflow first. And the workflow is basically your business logic, right? And temporal is a workflow based system which allows you to, as developers, to write workflows in the form of a code. There are some non-code based platforms that are drag and drop and that like may look convenient. At the end of the day, developers do care about code and they do feel flexible and really comfortable in being in the coding platform. So that's very appealing to a lot of developer audience. And temporal is a scalable and reliable runtime for executing all these durable functions called temporal workflow executions. If I have to say it another way, it's a platform that guarantees durable execution for all your application code. And it enables you to develop as if failures don't even occur. And your app will run reliably even if it encounters any problems, such as network outages, server crashes, which would be catastrophic for any typical application. So temporal platform will handle these kind of problems, allowing you to focus on business logic instead of writing application code that will detect and recover from the failures that are inevitable. Workflows will take care of all these things for you in temporal framework. Temporal's workflows will run in any number of worker processes that are maintained by you. And then it can be on-prem or cloud or it's agnostic. The code itself, the workflow code will be run by the workers, which will be maintained by you on any hardware of your choice. And the code in the workflow translate to events in temporal, which means that the workflow code can be replayed with the events on different workers as needed in the event sourcing in any event sourcing approach. Therefore, the workflow code must be deterministic in order to run safely. These can call out to activities. The workflows can make calls to these little functions called as activities, which also run on workers. And then there are these general purpose functions that they can do all the functionality in. There are clients that can signal, query, and cancel or terminate the workflows. These are external clients that will make these calls to the workflows. Temporal.io has libraries that are defined and will enable you to write clients of your own to temporal framework. And since workflow routinely waits on timers and async tasks, there are managed coroutines, there are cancellations, there are compensations, all these kind of the ecosystem elements. Workflows are modeled. They're also modeled as well in Java. Even in Java, there are. I will go into the detail at the end, but there are multiple things you can do with Java in temporal.io. So, what is a temporal application? The application consists of billions and millions of workflow executions, as I mentioned before, and these workflow executions are lightweight components, meaning an execution will consume few compute resources. If a workflow execution is suspended, such as when it's in the waiting state, the workflow execution consumes no compute resources at all. So the workflow execution is a re-entrant process, meaning it can be resumed, it can be recoverable, and it is reactive. So it has an ability to process to continue the execution after the execution is suspended on an awaitable thing, and it is recoverable, meaning it has an ability to process to continue the execution after the execution is suspended on a failure, and also it has an ability to react to external events. Now, getting onto the actual concept of durable execution, I want to double click on that a bit. What do we even mean by that? Um, so, durable execution is a new abstraction for developers that can fundamentally change the way they build and deploy and run these systems. It's considered as the future of event-driven architecture and can make all the developer distributed systems very reliable. But ultimately, it allows you to code for a single positive result you want to execute and eliminates the distraction of complex plumbing and error logic. Let's walk through some code using a simple money transfer example to give you a sense of what it is. What you're seeing on screen is a two-step money transfer flow con 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 constructed of a withdrawal process of where the money is withdrawn from a bank and then deposited that money into another bank account using the deposit method. So if you see that's the business logic, which is withdrawing and depositing, you're overriding that you are kind of implementing that workflow with the help of that transfer workflow implementation, and it implements all these interfaces. I wanted to show you. So it implements using the transfer workflow. Uh, you really have to define these in beforehand, and then there are these active process servers running on workers that will process all this kind of logic for you. Um, And then the withdrawal happened in a simple Java application. And then after the withdrawal happens, and then it moves to the deposit phase where you want to deposit money to an account. And then there's a blocks waiting for a response. Imagine there's a human in the loop or some person who's approving that deposit. Um, while we're waiting on that blocking call, let's say the process crashes. And we ask ourselves this question: what state are we in? Did the deposit occur? Did it not happen? In a normal system, we would have to have a plan in place, or when this happens, you'll have to code for this kind of an interrupt. But with durable execution, we can capture the complete state of function, including variables, threads, and blocking functions, so that we can simply migrate the program to another process or a server and rehydrate the state and continue on. So the response comes from the gateway, and the function can now just carry on the new server as if nothing really happened. The issue is resolved. You moved on to the deposit phase without even seeing the interruption. That's what durable execution does to you. It will handle the errors, it will move the process to another server, and it'll make it seamless for developers to handle this kind of error handling or exceptional situations. So, in a nutshell, durable execution is a system that ensures that the code and the app is run reliably, correctly, even in the face of disaster. And temporal is the tool that's powering, that is enabling developers to do this durable execution. So Temporal.io is an open source programming model and the platform that delivers durable execution. These people are the only leaders in the market who are doing it. I don't work there anymore, but I still love the product. So I insist, if you have time, for you to go ahead and try their product if you are looking for reliably building your distributed systems. Some of the capabilities of temporal are that it allows you to avoid code complexity, failure logic, and build state machines seamlessly. There are some key capabilities like auto-saving app state. So you will stop building the state machines really. The temporal will capture the complete state for your functions like blocking call, threads, and variables. So you do not have to, you don't need a complex state machine code. Temporal will take care of that for you. There are native retries, meaning that you can set retry policies and you don't have to code for them. Usually in Java, you can do it, or any other programming language, but Temporal has the constructs that will allow you to set the policies directly, and you don't have to really code for the item. It will allow you to define the retry policies for activities that are literally functions that you do not have to code for these kind of retry mechanisms. There are timeouts and timers in, like just like in Java, native Java. If you want to wait for 3 seconds or like 3 months, temporal IO will allow you to set and manage timers outside of your functions and allows you to signal and wake them up, like the processes that you don't have to function temporarily. You can put them to sleep and then wake them up without having to code for all of this. Similar to timers, there's schedules, which it's similar to crons, but don't you don't want a cron. Your temporal will deliver an ability to schedule a workflow, and which will pause, stop, and start the processes for you, not much like a cron job, but much more efficient manner. There are more granular controls you have in schedules. There are these human in loop situations where incorporate humans that will approve certain workflows. So using signals, you can interact with these processes and wake up a workflow from an external source like databases or API calls and even a human action. All of this is possible with Temporal's framework. There's language support, which is agnostic. There are like Go, Python, Java, and whatnot that's supported. There are other features like these features are offered by Temporal Cloud, but in open source, there are certain things that you can also do. Like you can have a local development model. You can first start with the current delivery system and then expand to other ecosystems in your environment. The most commonly used use cases, the leveraged use cases for Temporal.io are these that you see on the process. Anything that's backed by a process in the HR industry, the supply chain world, where workflows really matter, like payment industry, money movement, resource management, like payment gateways, where humans are involved. But things are mostly managed in a life cycle pattern. That's where you see temporal will add huge value, where you have a CI/CD pipeline, you have operational use cases like software upgrades, provisioning states, and maintaining state. Also, in the case of data pipeline development and maintaining those pipelines, all these are extremely relevant use cases for temporal. I want to get into a bit of how temporal actually works when you're using Java code, Java SDK. So it all starts with your code in your language, which is Java. You can use one of their SDKs. They have a Java SDK, JavaScript, TypeScript, Python, Go, and PHP. So use your favorite SDK, in this case Java, and you create a workflow. And a workflow is a central concept in temporal, right? As I mentioned, it defines an end-to-end process that you want to execute. It's a high-level definition that will use activities to execute the tasks you want to complete. Also note that a workflow needs to be deterministic, which means that every execution will be the same as there is no chance of variability. Next, using the SDK again, you compose your activities that will be part of your workflow. This is where your tasks are completed and you can do anything you need. There are the parts of this framework that can fail, and you can set the retry policies for them using the Java constructs. And the learning curve is extremely, like, really low. You really, because the beauty is that all of these are native to Java. You don't really have to learn anything new. It's just a new way to mold those libraries and APIs. Once you define the activity, you can wait for a second or a month, or some human will take an action, and then it'll capture the whole state for you. These activities can be in whatever language of your choice, and they do not need to be the same as the workflows. So the workflow can be coded in, let's say, Python, and then the activities themselves can be in Java. So yeah, you write an activity to hold the failure prone parts, and then the code will automatically retry upon some failure. Once the application is coded using workflows and activities, we then deploy it to a temporal worker. This worker will run the application and play a key role in automating the capture of state for the execution. All of this is run in your environment and requires no change to the way you build and deliver code. Other than that, you need to use temporal SDK. That's the only change you need to make. Um, if you have existing applications that you want to temporalize, it's extremely easy. You just refactor some of those APIs to using the temporal SDK. So the worker does two things. First thing is it captures the state and it sends it to the temporal server. It will continuously poll the server for tasks it needs to execute. The server isn't in control of these things. It simply captures the state and stores it in a database and has a running list of tasks called a task queue. This is where the timers and retry policies get queued and triggered. In case of a process failure, worker knows the state and where it was in the execution of a workflow. So it can restart and rehydrate any process. And that's how it works. The worker will start it and queue the tasks in the task queue, and then it will start to deliver each of these queue tasks to the relevant app. So the heading should have said Java. I'm so sorry about that. It goes the same way for Python or Java, which is how we implement activity that you're seeing on the screen is you start off like it looks very, very similar to how you would write a Java code and create the business logic. It's in this way, you just create the functionality within a certain function, you implement an interface, and then you'll try to uh, implement that interface into the workflows and activities that you want to use a certain pattern for. The same way, workflows are also, they would implement a certain interface that was predefined, and then we take it from there. I'll give you a second to go through the code. What it's basically is doing is that you define an interface. You also have certain functions that are converted into activities. In this case, we are describing a checkout workflow in an e-commerce setup where you're purchasing and where you're paying the money. So in this workflow, there is a cancellation involved, and then you are implementing your own interface that you defined previously. And then you run these methods, and then defaultly there is an exception that's getting handled, and there are retries that you can put in place. I mentioned running a worker, so workflows and activities are run in workers. Right? So how do you start a worker? Is you define a client that will implement that triggers a new instance of the temporal service, and then you create a workflow factory for managing the workers. And eventually you create a worker that will listen to the task you named, whatever name you have, and then it'll pick the task from the task queue. This is how you register the workflows and activities within a worker. There are APIs well defined, they're well tested. You just have to pick them and then use them on the go. And then you start the worker using the factory here. And then you log into the worker. It's you can also log. You can maintain your own log. Temporal maintains its log inherently, so you can use that as well. That's how you start things. And also we mentioned writing a client. These clients can actually signal, query, and update the state of a long running workflows or short running workflows. The way you do that is how that's described on the screen. So especially in Python, there is a facility for you to run Python async definition function, which when you run that, what happens is that like in this async io.sleep, it will sleep for 10 seconds. But the async io.sleep is not like that. There is time.sleep that you typically use. I'm just trying to tell the difference between a normal sleep and a temporal backed sleep. In this case, it won't sleep for 10 seconds. It does not block a thread or anything like that. Instead, it is more like a JS set timeout or a go time sleep, where it instructs the underlying scheduler or event loop to yield to another work and only resume after the time has passed. So that that way, it's similar to what you create. Like you can create an default event loop for the system and run until complete. It's like now this is for the Python, but there are similar constructs for Java as well. Some of the features that temporal workflow offers is that you will make sure that the things are durable. There are timers, the tasks, everything is task oriented. You can implement cancellations. There's a way you can make sure that the primitives are synchronized, and that there is a wait condition that you can implement. There are Rust-based features if you are going into Rust core-based languages like Python, but not if you're Java-based. You can implement cancellations and compensations. You can write like tasks that filter things for you, and then there are multiple functionalities like multiple activity styles that you can implement, and then club all of them into one single workflow. That's in a nutshell what you can achieve. If you want to go into detail, please contact me via LinkedIn or with, the Twitter. I'll be extremely glad to help you out to onboard you onto this really awesome platform. I wanted to give a gist of what Temporal is about and what features you can achieve so that you can kickstart your temporal journey. Thank you so much. I have included some resources here, and I'll make sure to link some more after this talk to the deck. I appreciate all your time once again. Thank you so much.